Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I want to continue our discussion on data and classification by talking about data presentation. And in specific, we're going to talk about the tabular view or raw data, and we're going to talk about histograms, because these are probably the two most common ways that we're going to visualize data when we're talking about creating classifications. Now, I want to be clear here and say that there are many, many, many forms of data visualization. There are many ways that we can compare different variables, and all of that is extremely important, but we're not going to talk about it in these discussions. We're going to limit ourselves to talking about the tabular raw data view, histograms, and then we're going to talk about some descriptive statistics like central tendency and dispersion. So just to recap where we left off last time, we had finished talking about the types of data with nominal, ordinal, interval, and ratio, which were basically just increasing levels of mathematical ability, with nominal being no math and no ranking, ordinal being no math with a rank, interval being mathematically inclined but a non-absolute or an arbitrary zero, and then ratio being mathematically relevant with an absolute zero. So what I want to do in this video is I want to talk about tables, and then in the next video I want to talk about histograms. So when we think about a table, right, or the tabular view of data, or tabular, of data. Typically what we're talking about is something very similar to an Excel spreadsheet or the attribute table that you see in ArcGIS, where you have rows and you have columns. Where each row in the data set constitutes an observation. Or in the case, actually let me see if I can make that a little cleaner. Where each row represents an observation, right? Or in the case of geospatial data, you might see these called a feature or a record, right? Each row represents some piece of data. Typically in GIS, it's a feature, so it could be a point, it could be a polygon, it could be a line, right? And then each column, by contrast, right? Each column, right? This represents a variable, right? So for example, column 1 could be population, right? And each row might be a census tract or a county. So then the value, right? The value in each row, right? There's going to be some number or word, right? Or some other thing, right? This is going to be the value for that variable for that observation, right? So again, if we were to think of this column 1 as population and each row as a county, right? The value for row 1, column 1, right? The value in that sort of where they intersect is going to be the population for that county. Hopefully that makes sense. Again, rows in the tabular view, rows are observations or features or records. You'll see those terms used interchangeably. And then columns typically are variables. These are the information or the data. So let's go ahead and let's look at a real example of the tabular view of data. So this is a snippet from a much larger attribute table for a data set from ArcGIS Pro, where we are looking at the population, and if we were to continue on farther down, we would be looking at education level for each county in the United States. And so what I want to do really quickly is I want to recap what we've talked about before by talking about the different data types. So in this little snippet of the table, right, we have the rows in this case, right? Each row is a county. Right? Each column, right? Each column is a variable. And so if we think about what we just said in the previous little segment here, right, this right here, right, this would be the area of Attuga County. Right, so that's that's the structure of the tabular view of data. And what I want to recap is the idea of data types. So each one of these columns, because each column is a variable, right? Each one of these columns is going to have a data type associated with it. So what I want to do is I want to talk about the ones that we see, what type of data is it? So let's talk about name. So that's this column right here. Well, name, right, if we remember back, nominal, ordinal, interval, and ratio, right, the name of something is a label, right? It has no numerical value, and you can't imply an order, right? You can't say that Autauga County is better or more important than Baldwin County. So in this case, name is going to be nominal. All right, let's talk about area. Area, right, if you have 0 area, that means you have 0 size. And negative numbers for area don't make sense. And area, by definition, is a numeric variable, which means that area is going to be ratio. What about ID? ID, we look at it, right? It looks like it's got some numbers, so you might think it's numeric. But in the middle, you see US, so it's not numeric. If you think about ID, right, again, it's a type of label, so we can't really say that 0500000 US 01003 is better than US 01005, right? We can't say that, so it doesn't have an order. So this would also be nominal. What about populations? So we have total population and total male population. Well, population, if we think about it, right, what does it mean to have 0 population? That means you have 0 people. So 0 actually means 0. And it doesn't make any sense whatsoever to have a negative population, right? So in this case, both population and male population, right, both of these would also be ratio. Right, so in this case, right, the tabular view, rows represent counties or observations, columns represent variables, the value within a column in a row represents the value of that variable for that observation. So in this case, this square here was the area for this county. And then we said that nominal for name, nominal for ID, and then ratio for area, population, and male population. So I know tabular view of data hopefully is a review. This is kind of the default way that we think of data. So hopefully this made sense. And as always, if you have any questions, please reach out. Thank you.